this year. But Eric's is a bit special because he added an element to his control flow in Arduino. He knows that there's an issue with the signal that he'll explain, and he used a microcontroller to fix it.
Hey, hi, I'm Eric. I'm a rising junior at Mills High School. My starter project was a big time watch, and this is my intensive project, which is an RC hovercraft. Let me demonstrate. It's gonna be loud, so. So let me explain how this works. So right here I have a controller, and inside I have a receiver which is connected to an Arduino, which wasn't part of the original plan, which I'll explain later. So the Arduino receives the signal from the receiver, and then it essentially remaps these controls so that, and it sends that signal to the ESCs, which are electronic speed controllers, and those take in power from the battery and convert it into signals for these brushless fans, so that they turn on. Then you have the lift fan, and it sends air into the skirt, and the skirt's the most important part of this. So there are two holes at the bottom, and basically what it does, it creates a high pressure air cushion underneath and generates a little bit of lift, which reduces friction so that the thrust mode can propel it forward. And like if I didn't inflate it, it wouldn't move at all. And it has to be on smoother surfaces. Like we tried it on the carpet and it just doesn't work. So obstacles I had, it was a really big obstacle. So usually in the original plans, I don't need an Arduino, but after like 6 electronic speed controllers, the controls were never right. What basically happened was at neutral, this fan was beyond, and to turn it off, I had to hold it back. So like after like weeks of researching and trying to pinpoint the problem, I just decided to use an Arduino to remap these controls so that the controls I would be using would be correct. Modifications I had, so obviously the Arduino wasn't planned, and that took a lot of time, so I didn't get to the modifications I wanted to do, which is ultrasonic sensor, which I'll try to do tomorrow, but just depends. And also the design of this whole thing. So this body I designed on SketchUp because I really wanted to have experience in 3D modeling. And so the hovercraft is loosely based on a couple of projects online, but the whole overall thing is what I designed. So through BlueStamp, before BlueStamp, I had experience in like hardware. Like I had an engineering class at school where I programmed a little bit, but it was still mostly hardware. I have a robotics club where I managed the construction team, and that's just building stuff. But through BlueStamp, I have exposure to programming and electronics, and just reinforced my interest in engineering. Thank you.
How did you identify that your ESCs were getting the wrong signal?
So after a lot of research online, we went through 6 ESCs, And at that point, you kind of realize that it's not really the ESC's fault anymore, and it's the receiver's, or the controller's fault, or the receiver. We still haven't pinpointed it, but yeah, so we just use Arduino, and the Arduino worked, and now we know it's the receiver/controller's fault.
Was there any particular tools or equipment that were helpful?
Oh yeah, the equipment that I got really familiar with was an oscilloscope. So I used it to check the signal coming out of the ESCs to the fan and the receiver to the ESCs. And we basically compared them to see if they're the same lengths. So basically the oscilloscope displays like the signal that you're sending, and you just examine like the period, and yeah.
You mentioned that you wanted to add an ultrasonic sensor as a modification. What would you use that for, or how does it apply to your project?
Oh, so basically what I wanted to do was that if it got close to an obstacle, the bottom would deflate, because I don't know if you saw, but like this thing's really hard to control if you have the lift still on, because there's really little friction and it just basically drifts. So I wanted to deflate it, and like once it got close, I wanted to deflate it and maybe like turn the servo like at a certain angle so that it'd be easier to get out of the situation. Because these fans are like really high powered. Like the first time I turned it on, it like shredded through like some foam and just spit it everywhere.
What is it made out of?
Something called Depron. It's basically just foam. Like a lot of RC planes and helicopters use it. It's really lightweight.
Did you have to carve it? Like, how did you put it together? Does it come in sheets?
Yeah, it comes in sheets, and I use an X-Acto knife to cut it, and there's also a special type of glue that sticks it together.
What could we do with the noise from the fan? Like, how could you reduce the noise? Or is that not part of the plan?
The only way would be to like reduce the power, but then it might not work as well. So just have to deal with it.
Basically, this is like the Hummer of hovercrafts.
Yeah.
It's like-